Welcome to the tutorial for designing anchors for concrete using Hilti PROFIS Engineering Suite. This tutorial is designed to walk you through each of the steps involved in this process. Let's jump in. First, navigate to the Concrete Design module from the Setup screen. To get started, select whether your base material is cracked or uncracked concrete. The default selection is cracked. Uncheck this only if the concrete will remain uncracked throughout its life cycle and supporting calculations can be provided showing concrete will always remain under compression. For this example, we've selected cracked concrete. Now we must choose the concrete grade from the drop-down box. C2025 to C5060 are covered by standard anchor approvals. Low-strength concrete is allowed for selected anchors and is designed according to the Hilti sofa method. For this design, we'll select C2530. Let's move on to reinforcement. Choose None when reinforcement is completely absent. Choose Wide when rebar spacing is greater or equal to 150 mm regardless of bar diameter. You should also choose Wide if rebar spacing is more than 100 mm with a rebar diameter smaller than 10 mm. Dense should be selected for all other cases, including if the degree of reinforcement is unknown. Highly reinforced concrete members actually have a negative impact on anchors with shallow embedment depths. For this example, we'll select Wide. Edge reinforcement works in the opposite way, in that the resistance increases with an increasing degree of reinforcement. Choose None when reinforcement is completely absent. This is the most conservative option. Closely spaced stirrups act as hanger bars. The effect of each of these settings differs from guideline to guideline. For this design, we'll select None. Concrete temperature affects the design performance of chemical anchors. Enter the maximum mean value over a typical day-night cycle in a number of weeks or months. The drilling method and the condition of the hole while installing the anchor are defined under installation conditions. This influences the anchors available for selection as well as their load capacity. To position the profile on the concrete, values can be entered in the 3D model or in the Menu tab. First, we must set the thickness of the concrete member. This limits the depth to which the anchor can be set. We'll set the concrete thickness to 200 mm. Next, set the position of the steel profile with respect to the concrete edges. This affects the amount of concrete activated for tension or shear loading. Here's where you can set the edge distance. We've set the distance between the center of the profile to the concrete edge at 300 mm. Now it's time to choose the type of load: static, seismic, fatigue, or fire. For this design case, we'll apply a static load with a compression load of 10 kilonewtons, a shear force towards the edge of 15 kilonewtons, and a bending moment about the y-axis of 10 kilonewtons per meter. A valid solution should have the anchor utilization ratio less than or equal to 100%. If we look to the right, we see a utilization of 180%, which means adjustments are needed. There are ways we can fix this. We could change the anchor, keeping the base plate dimensions and anchor spacings fixed, or we could keep the anchor fixed and adjust the base plate dimensions, anchor spacings, and number of anchors. Let's try the first approach. In the anchor selection window, we can go through each family type and size until we get a utilization of less than or equal to 100%. Or to speed things up, we can calculate all anchors that can be used with the same design inputs. In the filter settings to the left, we can show only those anchors which work. The first thing you may notice is that the utilization is 100% for all anchors. That's happening because the optimized embedment depth option was pre-selected. Here we see that HIT HY200 adhesive with a HIT Z M12 rod at an embedment depth of 133 mm provides a solution. By clicking on the anchor, we select it for this design and return to the main window. At the bottom of the anchor selection window, we now adjust the embedment depth to 140 mm by switching to User Selected Embedment Depth and entering 140 mm manually. Now you have the information you need to jump in and start designing anchor fixings in concrete quickly and accurately. We hope you found this tutorial helpful. For more information, please visit Hilti.com.